Alright, for this example, okay, so let's say if I want to find the delta H value for my reaction, 2 moles of sulfur reacts with 3 moles of oxygen gas, produce 2 moles of sulfur trioxide by using the algebraic method. Okay, so these two equations where I know the enthalpy here, I call it as the information given in the question. So again, to use the algebraic method, okay, I need to rearrange these two equations until I get my target equation. So let's have a look at the first equation. Okay, so 1 moles of sulfur react with 1 moles of oxygen, produce 1 moles of sulfur dioxide, where the reaction is exothermic with negative 297 kilojoules. Okay, so if I compare it with my target equation, okay, in my target equation, I need 2 moles of sulfur on my reactant side. But here, okay, the sulfur is already in the reactant side, but then I only have 1 moles of sulfur. So to get 2 moles of sulfur, I need to multiply all of this by 2. Okay, so multiply all of this, okay, including the delta H as well. Okay, so multiply it by 2. Okay, so this will give me 2 moles of sulfur solid plus 2 moles of oxygen gas produce 2 moles of sulfur dioxide. Okay, so here I'll label my delta H as delta H1, okay, equals to negative 297 times 2, so we will get negative 594 kilojoules. Okay, so now for sulfur, it is settled. Okay, 2 moles of sulfur, 2 moles of sulfur, reactant side, also reactant side. Okay, for the second equation, okay, so here I have 2 moles of sulfur trioxide, produce 2 moles of sulfur dioxide and oxygen gas. Okay, so the reaction is an endothermic reaction. Okay, but when I compare it with my target equation, the sulfur trioxide should be my product, but here it is in my reactant side. So what should I need to do here is I need to reverse all of this. Okay, so make it a reverse reaction. Okay, so for the reverse reaction, it should give me 2 moles of sulfur dioxide plus 1 moles of oxygen gas produce 2 moles of sulfur trioxide. So now, okay, I have 2 moles of sulfur trioxide on my product side. Okay, so the one that I need to change in my delta H here, let me let me label it into delta H2. Okay, so since 2 moles of sulfur trioxide produce sulfur dioxide and oxygen is an endothermic reaction, so once I reverse the reaction should be an exothermic with negative sign. Okay, so negative 198 kilojoules. Okay, so since I already used up these two information, okay, so now what is left to do is I need to add up these two equations together. Okay, so first let me check whether I have the same thing on the product and the reactant side. Okay, here I notice that I have 2 moles of sulfur dioxide on my product side and 2 moles of sulfur dioxide on my reactant side. So these two just cancel it out. And then when I add these two together, okay, since there is nothing left to be cancelled out, okay, so it should give me 2 moles of sulfur plus 2 moles of oxygen plus 1 moles of oxygen. So 2 oxygen plus 1 oxygen, it should give me 3 moles of oxygen gas. Okay, and then for the product, it's only give me 2 moles of sulfur trioxide. So this delta H, let me label it as delta H3. Okay, so now I will compare my overall equation with my target equation. Okay, so it is the same. Okay, so it means that I did it correctly. Okay, this is correct. So applying the Hess's law, okay, delta H3, I want to find the delta H3. It means that I need to add up my delta H1 and delta H2 and then substitute the value, and then you will get your final answer, which is the enthalpy of this reaction.